Number 14, evaluate the integral. We have the integral from -4 to 2 of the absolute value of x plus 2. I definitely suggest in this one, unless you'd like to do a lot of work, it's easier to draw a picture and then use geometry to get our area. So what we are going to do is draw a picture. Absolute value I know looks like a v, and I know specifically on this one, because if I plugged -2 in here for the x, my x value would be 0. That's where the v is going to be happening at -2. And then if we just wanted to pick a couple extra points to put in there, I usually like to put 0 in. So if you put 0 in for the x, you'll get 2. And then I'm going to go 2 the other way. So if I put -4 in, I would also get that value of 2. So that's what my v is going to look like. Okay, from here, it looks like we would like to find the integral from -4 to 2. So -4 until I get to 2. And so I notice on this specific picture we have 2 triangles, so I'll call this triangle A and triangle B. So to get the area under the curve, this first one's going to be 1/2 times the base. So if you just count the base, it's going to be 2. And then to get the height, since that's happening at x equals -4, if you plugged -4 into the absolute value of x plus 2, we already found out that we will get 2. So the area of A would be 2. And then for B, 1/2 times the base, if we counted 1, 2, 3, 4 units. And then to get the height, the way that we could get the height is actually plug 2, since this is over 2 units. If I plug 2 in for the x here, 2 plus 2 would give me 4. So that would be my y value there. So 1/2 times 4 would be 8. And then if I just add those two together, my answer will be 10. And actually, if you would like to use the fundamental theorem of calculus to do that, we would basically just split it up from -4 to where it splits at -2. This would be -x plus 2. And then the other one would be, boom, -2 to 2 of x plus 2. So it gets a lot trickier when you do that. But there we go. Okay, number 15, evaluate the integral. Use properties of integrals and the graph of the integrand in areas to evaluate the integral. Okay, using properties of integrals, there is a plus sign here. So I'm going to separate this into 2 separate problems. Okay, so then this one, and it then did it say to graph the integrand and find the areas. So this first one, the 2, would just look like a line across that 2, because it's just y equals 2. And we would like to find the area under from -7 to 7. Okay, so then that's just a rectangle, so it's going to be 14 times 2, which will be 28. So that area will be 28. Okay, to get this one, hopefully you're familiar with what the square root of 49 minus x squared is. It's just a half circle, and the radius will be 7. Looks something like that. It should look more circular, I suppose. So we're just finding the area under this. This is a half circle, so it's going to be half times pi times the radius squared. The radius is 7, so it'll be 7 squared. That will give us 49 halves pi. And now we just add those two together. So my final answer will be 28 plus 49 halves pi. And that will be the integral. Okay, number 16, evaluate the integral from 1 to 4 of 2 over x to the 3 halves dx. This will be using the fundamental theorem of calculus when we do this. So first thing that I'm going to do is bring my power up top. So I'm going to have 2x to the -3 halves. And then from here we can use our power rule. So I'm just going to leave that 2 hanging out. We could easily just bring it up front as well. So we're just going to let it tag along. Okay, I'm going to add 1 to my power. So -3 halves plus 1 would be -1/2. And then we multiply by the reciprocal on the outside, so we're going to be multiplying by -2. And then from here we'll have -4 x to the -1/2. I have a hard time plugging things into negative power, so I'm going to make that a positive power, so -4 over. It will become x to the 1/2 on the bottom, or actually the square root of x. So now we're going to evaluate it at 4 and at 1. And I do like to put these brackets because it's alerting the person that's reading my paper what I'm about to do next. So now we're going to plug in 4. So I'll have -4 over the square root of 4. And then we'll subtract when I plug in 1. -4 over, put that in parentheses even, the square root of 1. Okay, so the square root of 4 is 2. Negative 4 divided by 2 is negative 2 minus the square root of 1 is 1. Negative 4 divided by 1 is negative 4. These are going to turn into pluses, so negative 2 plus 4 will give me 2 as my integral on that one. Okay, 17. Express the desired quantity as a definite integral and then evaluate. Find the amount of water lost from a bucket leaking 0.4 liters per hour between 8:30 and 11. Okay, my key here is liters per hour, so when I take the integral of that, I will just be left with liters, and that makes sense because it says find out how much water I lost, so that would be measured in liters. I'm going to go from 8:30, which would be 8, halfway through the hour of 8 and 11. And how fast is it leaking? It's leaking at 0.4. And I guess we could decide, since it's per hour, I'm going to use dt for this one. So now from here we have our integral set up, which is what it asked me to do, and then I'm going to evaluate. The integral of 0.4 would be 0.4t, and then I'm going to evaluate it at 11 and 8.5. 0.4 times 11 would be 4.4 minus, then if I plug in 8.5, 0.4 times 8.5 is 3.4. 4.4 minus 3.4 would just be 1, and we wanted to know the amount of water, so it will be 1 liter was how much was lost from the bucket over that time period. Okay, number 18, the functions f and g are integrable, which means we can take the integral, and the integral from 2 to 8 of f is 6, and the integral from 7 to 8 of f of x is negative 3. And it said to find the values of the following definite integrals. This first one asked me to find the integral from 2 to 7 of f. So once again, what I like to do is make a little chart. I can notice from 2 to 8, my integral, that whole thing is going to equal 6. And then it tells me from 7 to 8, my integral is negative 3. And what this question is asking me for is what is the integral from 2 to 7. So I can see from this I'm going to take the whole entire thing and subtract the part that I already know. So 6 minus negative 3 actually would give me 9. And if you look at this, it just makes sense, because if I take 9 plus negative 3, I do get an answer of 6 for my total integral. Okay, and then part C, the integral from 8 to 7 of 4 f of x. Well, I see a couple things wrong with this. First of all, I'm going to bump the 4 out front. And then the second thing, we're not allowed to go from 8 to 7. We have to go from 7 to 8. So that's going to make a negative answer for that. And then we just have our f of x. And it was given to us that the integral from 7 to 8 of f of x was negative 3. And then times the negative 4 that was sitting outside, my answer will be 12 for that one.